we now talk about the we now talking about the cluster workflow in the Kubernetes. Suppose we have this cluster. Suppose we have that cluster. One moment, if I can use that, so I will save my time here. Okay, we can use that. We can use that. Yeah, we can use that. So this is our cluster. This is our Kubernetes cluster having the master node and the worker node. Now, how the things happen here? Suppose out of cluster somebody mm, right, this I just it. What will they use? Okay, suppose this is our cluster that marking with light blue lines. Okay, and in out of cluster, one admin wants to communicate. One admin wants to communicate in the cluster. Okay, so this is users. We can consider this is our user. Now, user want to communicate for any purpose. For any purpose, want to communicate with the cluster. Now, what happening here? It is fast reach to the QAPI server. Any problem here? Any doubt? Because if you understand this point, so many things will clear here. It helps to clear many doubts here. Now, what happened? What happened? This is a basic comment that anybody can run in the cluster. That is kubectl git port. You just want to know about the cluster port. So fast, when QAPI receive your request or any query, first it will check your authentication. What does mean? That means you are authorized person to take entry in the cluster. That is called the authentication. That will first check. Then it will validate your request. What kind of request you are uh, throwing, or you can asking to the QAPI server. Means you are asking for the cluster that it will check it is valid or not valid. Why not valid point is coming? Because in the kubectl, in this cluster, kubectl is your valid command starting. Means starting a syntax that we call syntax. So inside the Kubernetes cluster, only kubectl work. Okay, you cannot use your Docker. So that is one thing that user your request can validate through that. You still get port in the inside instead of port you are writing Docker. So it will not valid for the your Kubernetes cluster. So that is called the validation of the request. So that is the second point. It will check. Third point, it will retrieve the data what you are asking for, and it will give to you. That means that it will take the data and give to the you. So whenever you asking that, what you still doing here? First, it is doing the Second, it is doing the request validations, validate or validation, the same point three. Then so these are the first 3 points it will do. Point number one, point number two, that will work in the same time. Okay. Point number three. This is your point number three. Because it will take data from etcd only, no other point. Any problem, anything here, guys?
No.
Thank you. Now, now what I will do for you, I will just want to show what's happening. I will just want to show one thing. I will just want to show you one thing. Just let me open that. Oh, guys, what we have in the cluster. Suppose if I talk about this cluster, what we have? One is master node, another is worker node. Is that yes, no?
Ye- Yes, yes.
Okay. So now
Yes,
I
sir.
am I am inside a cluster. I am inside a Kubernetes cluster. The the version of this Kubernetes cluster is 1.31. As everything has a version, right? Every platform, like whatever you want to deploy or working, uh, any platform that may be your OSS, that may be your any CLI, so that have a version. So we have 1.3. Now there is some certain command set that you need to learn. What we can see here, guys, tell me. Control plane, note one. Anything you able to relate what I discussed, what I taught? Anyone? Anything you able to relate? Himangsu,
There, there is one control plane and one node.
one note, what note?
Might be
Worker.
the worker node
Control
and
plane, control plane is
Work.
a master node and node is a worker node.
Correct, correct, Majamal. So as we are learning the theory, parallelly I want to show the things how it's actual cluster designed. This is our ready-made cluster. I did not design this cluster, okay. But whenever you have the opportunity, whenever you will have the opportunity, you can create. First you learn, then you can able to create. So here we clearly can see we have control plane, that is master node. We have a node 01, that is worker node. In this cluster, this is the ideal scenario. Okay, we got that. Now come to this picture. What I have right here, QCTL get what? See, why I able to launch in the cluster? Now I am inside a cluster, yes or no?
Yes.
Yes, we are in the cluster.
Okay. Now tell me how I enter into the cluster. Who gave me the permission Who gave me the access to enter the cluster?
API server
Cube API server.
Okay, that is correct. How?
using authorization via etcd.
Actually, this is not authorizations. Authorizations are a different thing. It is authenticate. User authentications happen.
Authentication.
Yeah, means proper user ID password.
Access and those things.
Yes. So that's why I able to launch here. That's why I able to enter inside the cluster. So now I am inside this. Yes or no? In this blue border.
Yes.
So first part is done. That is what? Authentic. I am just showing here user authentication. So number one, we have completed, right? Request validate. I already request one thing. The request was QCTL get knocked. I request. I fired this comment and in response it give me the print output result. So already we have got that. The 3 points we have got that. Request validate first. It did the validate of my comments. That was I just so I fire this. It's validate. Then retrieve data. What it give output? It's give output like it.
That's control plan node
Mm,
information.
yes. So that's what we get. So retrieve data and it's give to me. So that means it's already retrieved the data, 3 number, 4 number, it's returned back to user. This is the both way. QAPI server first forward my
But
request to the
Nandan, I have
etcd.
one
One
query.
point, 1 point. Amit, just one moment.
Oh,
Just
okay, okay.
QAPI forward the request to the etcd. etcd fetch data inside it. It has a real-time data, as I already told you, and reply to the QAPI server. Now, QAPI server give response to the user what and how that I'm telling. This is your number point 4. That is your getting output. So, so what is my point here? I fire this. I execute this. It first goes to the API server. API server forward that request to the etcd. etcd retrieve data insight from itself and give to the API server back, and then API server throw the output to me, and that time I am getting this. In this flow, anyone have any confusion, any doubt? Let me know first. Then
No, we
I will
don't have
come to Amit.
confusion regarding this commands. Like, is it validated in Cube API server? Like, if we have any library or something in Cube API, or it's in etcd.
See,
Like,
uh,
and kubectl get not. If you try Docker, it will not run. So this identification of kubectl Docker, it must have some library.
I am telling you,
This is
I'm telling you, I understood your point. These are the you know primary and very major components that we have here, that we draw here. These are the very primary and major components. As example, you are writing the kubelet, right? So kubelet is the agent. So we have to install the agent. You are talking about library. Actually, not like that. Agent we need to install inside our cluster. We have a ready cluster. I told you we have a ready cluster. These are the things that we need to deploy one by one during your cluster designs. You got my point? Like the kube proxy that you have to install. Otherwise, it will not work. It will not get understand what you are running. So these are the components we have to install before starting our work. Only part that not required to install. Otherwise, all these components you have to install to define your cluster. Amit, now your turn. Tell me.
Okay. You just fire the comment and we get the one is control plane and one is node one. But not mention that which one is master node and which one is worker node.
Amit, you missed that. Whenever I fired the comment, I asked to everyone. Some of guys answered that. Control plane. See, it is also measure here. Control plane. You can see. It is not the
Mm-hmm.
first day I am talking about. Control plane means your master node. So it is your master node.
Okay, okay, okay.
Yeah, when I mention the node 01, that is your
Hmm.
worker node.
No, worker node.
Yes.
Okay, okay,
Okay, fine.
okay.
We can move to next. Right?
Okay,
Yes,
yes.
no.
Yes, yes, you
Okay.
can move.
Right. Now, try to fire another comments. What I will fire? QCTL get what? Earlier, what I find? No. Now, what? No resource found in default namespace means we have a we have a node, but we don't have the port. So we need to create a port. We need to create a port. Now, who will help me to create port?
Actually,
Why?
what is the means of namespace?
That is some object and resource in the Kubernetes cluster. I will go
Mm-hmm.
one by one so that you
Okay, okay.
you should not have any problem, right? So that is the reason I did not discussing on that. Now, who will help me to create the port? Anyone?
She, she, yeah, the Docker engine.
Amit, we are
CRI.
okay. No, no. I'm asking who will help me to create a port. हम लोग यहाँ पे एक पॉट क्रिएट
Yes,
करेंगे देखो.
kubectl create pod,
ओके
space
ओके
some name.
ओके गुड 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 ट्राई. एनीवन? So what is port?
You are asking command, which command we need to put here?
Yeah, first tell me what is port. Tell me.
A pod is the smallest part of Kubernetes cluster. That
Okay,
application which we are running, it's written in like code are written in inside the pod.
okay. See, whenever anyone asks in interview what is port, don't tell them it is a smallest unit in the Kubernetes cluster. Okay, you can tell it, but it does not have any meaning. You can tell them. Okay, but point is you have to tell exactly what port is doing. What is the functionality of port? Like it's just helping to containerized applications to run inside the cluster. It is helping container to communicate. So these are the major point you have to mention. Fine. You tell me the port. You just told the port. Okay. Now we does not have the port in the cluster, but we have to know. Someone tell me. I think QGTL.
Apply hyphen F.
QCTL.
QCTL run pod name.
QCTL run port
Run.
name. Okay. So this is
Yes.
our
It-
test port. Okay. Okay. Understood. Understood. Now just see what I'm doing. QCTL run port. This is my port name. Test port. Okay. But guys, tell me. So we are just doing the port. We are naming the port. The yellow color we are naming as a test port. Yes or no?
Yes, yes.
But what we need,
Image.
It should
image,
be .yml file.
We need a space name space.
okay. Anyone? Yeah, we required image that is purely perfect. Now, if we put image, so suppose we are also giving an image. Suppose the image name is ngina. That is one image name, okay, for your information. We also putting one image. Now, what it will happen? How it will work? See the diagram and let me just explain me. We have a diagram pod. The pod name we are giving test pod, and the image we are putting here ngina. That is valid image. Image. Now, what happening with that? Himanshu?
Sorry, I don't know about this.
Okay, Majmal.
Actually, so
It will create a port with the image nginx.
Great. So, who will help? Which component take participate to help? Guys, I want take a concept, okay? Then
The
you
component
can
which
you
is
can
filter
clear
CRI,
your interview.
CRI will help. CRI will help.
Yes, Amit, you are correct. You are absolutely correct. The container engine, guys, you not. I think you guys not studying, okay? You guys not just taking the classes and enjoying. Just give 30 minutes in every class, so you will understand. See, we have a engine, container runtime engine. What is the name here? Docker engine. That is one container runtime engine. Okay. Yes or no?
Yes.
Okay, fine. We are taking one image. What is the image name?
BB
ngINX.
image.
Nginx.
Yeah,
Nginx.
ngINX. Now, this image, we use the Docker engine, means CRIO, to create the container. Now, coming to this point. So, the nginx image, we fit to the CRI. And CRI, what will give output? Containerized applications. Guys, this point is very important. This point is very important. Okay. It is fitting. And what is it's giving? It is giving you TA. That means containerized applications, not the test pod. TA. Containerized application. Yes or no? See,
Yes.
this is the syntax
I
of your Kubernetes.
Nginx
So what it is showing? Pod is pod.
created.
Name test pod created. Is that clear till this point? Yes, no?
Yes.
Okay. Now what happening inside this cluster that I will show? So suppose our one of group member doing qctl run test pod and minus image. This is basically hyphen, not minus. Image, then the image from ngINX that I have fired in the cluster. Yes or no, guys?
Yes.
Yes.
Okay. Now qctl run test pod hyphen image ngINX. That this user, the triangle is a user fired. So what happened? It's come to the QAPI server. Yes. Now, API server. Now, what happening in the API server? Giving this information to that this is the thing coming to me. It is the server save the information inside it. This is number 5. This is number 5. Save inside it. Again, it return back. What it is the server telling with the return back? Return back will tell that these are the node we have. Suppose here node 1. So it may be node 2, 3, 4, anything it can have. So that information he directly sent to this. Now, QAPI server send that information to the scheduler. This is number 6. That scheduler, we have an request for creating a pod, and these are the nodes we have. Now, scheduler will try to launch this. Now, scheduler will respond back with some information. What information scheduler will share? Scheduler will share, okay, as per my configuration, as per the my data, we have node 1. No, we need to launch this port in the node 1. Now, what happened? QAPI server inspect that node 1 kubelet. I am considering now this is node 1. Guys, try to relate my point. I am considering that this is node 1 worker node. QAPI server now give that instruction to the kubelet to node 1's worker node. And that is your number 8. Through the proxy, means it first what it will do, it will create a port. Simply it will create a port. That is point 9. And how the port is creating? I described everything. This is our point 9. I'm sorry. Here is some mismatch in this drawing. Like it is not straight. So in the point 9, we creating a port. There is a mechanism to create a port that I described. After creating the port, you will inform to QAPI server, both as per your instruction. I have launched the port. The port is working. So this is the QLED job to inform about the port, to inform about the containerized application status, monitoring and their status. It will update QLED to the QAPI server. After launching the port, it also inform that port is created and it is working fine. Now, QAPI server will give that information to the etcd server that this request we had, it is successfully launched. We resolved the request. We now launch a healthy pod with the containerized application and it is working fine. So etcd server reserve that information, keep inside it. That is basically called the real time. Immediately it responds back to this QAPI server. Okay, friend, I just updated your information inside my database. That is number 11. Now, now, now QAPI server informing to me that is point 12 point 12 your port is created. How it is telling me? I am showing this information giving to number 12 port slash test port created. So that is the number 12. This is the final statement from the cluster to me as a response, as an acknowledge that I have tried to port a launch and it is created for me in this flow. In this flow. Anyone have any confusion?
During this flow, kubelet will not speak to kube proxy to get some IP.
No, I told whenever any new service launches, proxy give IP, assign IP to this new service and give a name to this new service. After that, pod communicate through the service. I will come to that point in my after
Okay.
few lectures. I will analyze that also.
So in this case, when pod had been created and kubelet informs QP API server to store information of test pod, it will just save the name of the test pod only. There's no other
Not only
information
that,
like what is
details of the pod, like what image it has, so that
okay.
everything will show. I'm telling, I'm just want to say, I'm just want to show you now. These are the few comments. These are the few syntax you have to learn. See, this is test pod. This is ready and running. Who is telling me? Who is telling me? Hewlett. I launch it back. I launch it back. Uh, one moment. Sorry. Hmm. 7 minutes back I launched. 7 minutes 32 seconds back I launched that pod. Every 5 seconds, Hewlett updating to the QAPI server. So that's why we are getting the running. This is your current status, not like back 7 minutes. This is your current status because every 5 seconds it is updating. This is test pot ready one by one means your pot is ready. Can anyone tell me why it is one by one?
Because we are not using any controller mechanism, we didn't given any replication or those kind of things.
No, not like that. Sikandar, just we use the one image. Image name is
Okay.
nginx to make one container. So that's showing your containerized application having one and one is up to date. Means you have one and one is ready.
Okay. One pod and the running state.
One pod running state means you have one containerized application. This is your containerized application actually deployed, and this is the status of how many containerized application running and live.
Got it. Got it. Okay.
Okay. And what was your query? I missed that.
I just asked that what were the informations responded back like related to the pod.
Okay. Okay.
Like when you had given a O wide, it had given IP and all those
Okay.
things.
Okay. Okay. Now I am coming to this point. There is a reason that I fired this comment. See, now it has one IP. The IP is dynamically assigned to the pod from the cluster. And as we require to communicate to the IP only we able to communicate. That's why we're launching pod and we